Hello there, this is Miss Nakayama. Today's lesson is P.6b, multiplying and dividing rational expressions. So our objectives in this lesson are specifically multiplying and dividing the rational expressions. So please know that I will go through it very quickly because this is not where I'm going to concentrate on the factoring. That's previous lessons. It's all about just the multiplying and dividing. So first off, the steps to multiplying is you have to factor, which is what we talked about in P.5. Then we will divide any common factors. And after we do that, we will multiply the remaining factors in the numerator and multiply the remaining factors in the denominators. The main deal with that is that we are going to basically just multiply straight across. And I'm going to tell you most of the time, we don't have to multiply those in the denominators. We're only going to multiply that in the numerator. Okay, so first example that I have, multiplying rational expressions. The three steps that we just talked about on that previous screen. The first one is to factor. So to factor, I'm going to look at this first expression, x plus 3 over x squared minus 4. Well, the top is x plus 3. That's already factored. The bottom is the difference of two squares, so that's x plus 2, x minus 2. Then I go to the top of the second one, x squared minus x minus 6. That is x minus 3x plus 2. The bottom is a PST, perfect square trinomial of x plus 3 quantity squared. At this step, you need to be aware of our denominator and what x cannot be. So remember, we're looking at it and saying what makes the bottom 0. So each factor, in the first factor, x plus 2, negative 2 makes it 0. Positive 2 makes the second one 0. And then that last one, x plus 3 quantity squared, is going to be negative 3. So our next step is to divide. Okay, so divide, I'm looking for common factors on the top and the bottom. So I have an x plus 3 here, and I have 2 of them in the bottom, so I'm just going to cross it out right there, and that lets me know that I still have 1 left. Then I have an x plus 2 in the bottom and an x plus 2 in the top. So that's all the common factors that I have. So I'm going to multiply the numerator. Well, there's an only thing in the numerator is x minus 3. You do not have to multiply out the denominator, so I'm just going to write both those factors. I do have to remember what x cannot be. I got to carry that down, and x can't be negative plus or minus 2 or negative 3. So that's my answer. All right, look at this next example. I have x squared minus 25 over x squared times x squared minus 5x over x squared plus 3x minus 40. So again, first step we're going to do is factor. So x squared minus 25 is the difference of two squares. It's not a common GCF like this guy right here. It's not a common factor. That has a common factor. This doesn't have an x in it. So this is the difference of two squares. So I have x plus 5x minus 5. And on the bottom is x squared. I did not want to do that. Anyway, it's x squared. Then go to the next numerator, x squared minus 5x. That has the common factor of x, leaving me with x minus 5. And the bottom, you already saw that. That's going to be x plus 8 and x minus 5. Again, got to make sure that we remember the denominator cannot be what makes that 0 is 0, and then negative 8 and positive 5. Okay, so now I'm going to divide. So to divide, what do I have in common? Well, I have an x minus 5 and an x minus 5. And it does not matter which one of these I crossed out, y'all. I could have done these two or I could have done this. But if I have one in the top and one in the bottom, then they are a common factor that I can get rid of. Okay, I have an x in the top here. I have 2 of them here, so I'm getting rid of 1 of them. And it doesn't look like we have anything else. So now I'm going to go and multiply my numerator. My denominator, what's left in the bottom, is an x and an x plus 8. And on top, I have x plus 5 times x minus 5. So hopefully you can see if I had crossed these two out, then I'd be left with that, which is multiplied for you right there. So that's x squared minus 25. and I have to carry down what x cannot be, and that is 0, -8, and 5. And that's what we got. Okay, one more multiplying, and then we're going to talk about dividing. All right, so look at this guy. I've got x squared minus 9 over x squared minus 6x plus 9, and then I have 6x minus 18 over x plus 3. So again, I'm going to factor the top. X squared minus 9 is x minus 3x plus 3. On the bottom is that PST. So y'all, we're getting the same kind of thing over and over again. That is x minus 3 quantity squared. Okay, in the next expression, 6 is a common factor, leaving me with x minus 3. And on the bottom, I have x plus 3. So now I'm going to divide, and I have an x minus 3 and an x minus 3, which is 2 of those right there. And then I have an x plus 3 and an x plus 3. So what's left? Don't forget this guy right here, y'all. If that guy wasn't there, I hope you know the answer would be 1, because everything on the top is the same as everything on the bottom. Okay? But it's not. I do have a 6 left. So I'm going to multiply the numerator, but all I have is a 6. So I got my 6. I got to remember that, I didn't finish up here. X cannot be 3 or -3. And so we've got to keep that. Even though it looks kind of funny, it's still part of the answer to this problem. Okay, let's talk about dividing. Dividing rational expressions, just like dividing fractions, because our rational expression is a fancy way of talking about a fraction. It just means it's going to have a variable in it. So the quotient of two rational expressions is the product of the first and the multiplicative inverse of the second, or the reciprocal of the second expression. Okay? So just like you've said before, okay, you multiply by the reciprocal. To divide fractions, you multiply by the reciprocal. Y'all might have heard that as keep, change, flip. So I'm going to kind of concentrate on saying keep, change, flip, because more people tend to remember that than multiplying by the reciprocal. But it's important to understand the terminology. Okay, so I am dividing two rational expressions. I'm going to factor when I go to the next step, but I'm going to keep the first fraction. So when I keep that first one, when I go to that next step, I'm going to factor it. X squared minus 2x plus 1 becomes x minus 1 quantity squared. On the bottom, I have x times x squared plus 1. Then I'm going to change my division to multiplication, and then I'm going to flip the next one. So when I factor it, I'm going to factor the bottom, but I'm going to write it on top. So when I factor that, it has a GCF of 3, and then what's left is x squared plus 1. And then when I factor the top, I'm going to write it on the bottom, and that's going to give me x plus 2x minus 1. And again, still got to remember what x cannot be. So I got x cannot be, looking at our first fraction, x cannot be 0. And this, y'all, there's no way to make this thing 0, because if x squared is always a positive number, and if you have a positive number and add 1 to it, it's always going to be positive. So it can never be equal to 0. That's why it's prime also. A whole nother story. Anyway, and then what makes this 0 is -2, so we have -2 and then +1 from the second expression. Okay, so what do I do next? Find anything that's the same on the top and the bottom. I got an x squared plus 1 and an x squared plus 1. I have an x minus 1 on the bottom, and I have 2 of them over here. So what am I left with is, let's go with that's on the bottom. I got x plus 2. Oh, I know what I was supposed to do. There's my fraction bar. So I'm going to have x and x plus 2 on the bottom. I do not have to multiply it out, and apparently I didn't multiply it out on top. I did multiply it out on top. 3x minus 3, because I'm just multiplying this 3 right here times x minus 1. I still have to remember what x cannot be. I got to carry that down, 0, -2, and 1, and then I'm done. And you might see sometimes our program lets you leave it as 3 times x minus 1, and sometimes you have to multiply it out. So you just got to play it by ear and pay attention to what they're asking for. Okay, number 5. Same kind of thing. We're going to keep, change, flip. So when I keep the first one, the top, 6x squared plus 9, only has a common factor of 3, leaving me with 2x squared plus 3. The bottom does not factor. I'm going to change my division to multiplication, and then I'm going to flip when I factor the next one. So on top, I'm factoring x squared minus 4, which is x minus 2x plus 2. And on the bottom has a common factor of 5 times 2x squared plus 3. So now when I'm going to, I got to remember what's on the bottom. What can x not be? X cannot be negative 2 positive 2. And again, this is one of those things, y'all, where that's squared and it's always positive. And so there's no way for this thing to be negative, never can be equal to 0. Okay, so the only one I had to worry about was 2. Okay. There is another one. My bad. Because when you flip, and did I talk about it up here? Oh, no, because I didn't have to. Okay. So when you flip, you have to remember that because this was once in the denominator, you have to look at the numerator. You have to look at the whole thing when you flip it. It didn't matter up here because that was x squared plus 1 and it couldn't be. So that's why I didn't talk about it. But when you ever divide, you've got to, and you flip this fraction, you got to look at both parts of it. So 2 makes this thing 0, and what makes that 0 is negative 2. Okay, now looking to, what do I have on the same as on the top and the bottom? 2x squared plus 3, 2x squared plus 3, an x minus 2, and an x minus 2. So I'm left with 3 times x plus 2, and on the bottom is, looks like I just have a 5. And so on the top, multiplied 3 times x plus 2, I get 3x plus 6, and I have to carry down what x cannot be. And that's it. All right, last example. All right, and so look at this one because it just basically combines both things that are in this section. And my guys won't let me. Anyway, all right, so I have 3 expressions here. 1, 2, 3. So it doesn't matter the order that these things are in. If you're dividing, then you got to flip on the next step and multiply by the reciprocal. Okay, so this first one is going to give me 6x squared on the bottom. That does not factor. On the top, I have a common factor of x, and I'm left with x squared minus 25, which hopefully y'all have seen enough to know that's x minus 5 times x plus 5. Then on the next expression, on the bottom, I have x minus 5, x minus 1. And on the top, I have a common factor of 2, which is leaves me with x squared minus 1, and that becomes x plus 1, x minus 1. And then I come to divide, so this time I'm going to multiply by the reciprocal. So when I factor 7x plus 7, I'm going to take out a common factor of 7, leaving me with x plus 1, and I'm going to write it on the top. And then on the top, x squared plus 5x is going to be x times x plus 5. Okay, what can x not be? X cannot be 0 in my first. Okay, there's no adding or subtracting. There's just an x, so that's 0. Then I have 5 and 1 and negative 5. And yeah, this is 0 again, but because we already wrote it, we don't have to write it again. Okay, so what do I have that's in the top and the bottom? Whoops, don't do that. I got an x here and an x there. I have an x minus 5 and an x minus 5. I have an x plus 5 and an x plus 5. X minus 1, x minus 1, x plus 1, x plus 1. Holy cow. LOL. Y'all, those things don't cancel. They're not on the top. So x was on the top and the bottom. X minus 5 was in the top and the bottom. X plus 5 was in the top and the bottom. X minus 1. I was just going a little strikeout crazy there. So what I'm left with is 7 times x plus 1 quantity squared. Okay? When you multiply that out, that's what it looks like, because x plus 1 quantity squared is x squared plus 2x plus 1. And on the bottom, oh, look, I missed this little cross out. 2 and 6 leaves me with a 3x squared on the bottom. And I still have all of my numbers that it can't be, plus or minus 1. Oh, I left that one off because I didn't do the top and the bottom. All right, that's all we got. So what did we talk about? We talked about multiplying and dividing rational expressions. I hope you can tell me what you think is most important for you to remember these concepts. Hey, thank y'all for watching, and you have a great day.